This is 9.1b of algebra. So we've graphed some parabolas already, but now we're going to graph one that's a little more difficult, but not a ton. So we're going to add on a number at the end there, okay? Whenever we add or subtract a number, it's either moving up or it's moving down. Okay, so we're going to make a table. So we've got our x's. And then, so we're trying to graph this equation here, x squared minus 3. What I'm going to do first is graph the simplified one, so the x squared, or I should say rather make the table, and then we'll graph it. And then we can do x squared minus 3. Okay, so at first it should be like what you've done before. So I'm going to plug in -2, -1, 0, 1, and 2. Okay, so -2 squared is 4, positive 4, right? Negative times a negative. -1 squared is a positive 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. Okay, so let's start by graphing that. Oops. I'm going to graph it over here on the edge. Ooh, that's a little rough. Okay, so we said 0 went with 0. -2 went with 4. -1 went with 1. Positive 1 went with 1. Positive 2 went with 4. So if I attempt to connect those, oops. This is y equals x squared. So now what I'm going to do is I'm going to take those numbers, right, because that's x squared, and I've got x squared right here, and I'm going to subtract 3 from them. So 4 minus 3, that's 1. 1 minus 3, that's -2. 0 minus 3, that's -3, and I get some repeats now. 1 minus 3, that's -2, and 4 minus 3, that's 1. So now I can graph those points. So at -2, we're at 1, and at +2, we're at 1. At -1 and +1, we're at -2. And at 0, we're at -3. So we graph that using the points that we found, right? Y equals x squared minus 3. The other way we could have done it is just moved each of these points down 3. Okay, 1, 2, 3. 1, 2, 3. 1, 2, 3. Either way works. Okay, so when you drop an object, the distance from the ground, or the distance that it's fallen, is a parabola. Okay, so you can see we're given an equation here. It's got t squared in it, right? So we're going to use this problem. We're going to do our own. This is talking about an acorn dropping from a tree branch. So we're going to do an acorn dropping from a tree branch that is 70 feet above the ground. The function h equals -16 t squared plus 70 gives the height h of the acorn in feet after t seconds. We're going to graph it. We're going to see what time does the acorn hit the ground. So we've got h equals -16 t squared plus 70. Okay, so I'm going to put this in a table. T is our place of x. Okay, I'm going to split this up. I'm going to put the -16 t squared here. And then I'm going to put the -16 t squared plus 70 over here. Okay, so I'm going to do this in 2 parts. We are talking about time. It doesn't make sense to have negative seconds, so I'm going to start with 0. Okay, -16 times 0 squared. Well, 0 squared is 0 times -16. That's just 0. So over here we get 0 plus 70, which is 70, which makes sense. After no time passing, the acorn is still on the branch. And now I'm going to plug in 1. So after 1 second, let's see where we get. So -16 times 1 squared. 1 squared is 1 times -16. That's just -16. Right? And -16 plus 70 will give us 54. So after a second, it's 54 feet above the ground. Okay, then I'm going to plug in 2. So negative 16 times 2 squared. 2 squared is 4. Okay, so 4 times negative 16 gives me negative 64. Negative 64 plus 70, well, that'll give me 6. So it's now 6 feet off the ground after 2 seconds. So it's pretty close to hitting the ground, right? And it's speeding up, and this is why we're using a quadratic or a parabola. Because between 0 and 1 second, we only lost 16 feet, or only went 16 feet. Whereas here, we dropped about 50 feet, right? So it's speeding up and it's moving faster. So I don't need to jump to 3. I don't even think I need to jump to 2.5. I don't know that I even need to jump to 2.25. Why don't we check out 2.15? And if this is wrong, oh well, I'll redo it. Try another one. You're not necessarily going to hit 0 exactly, but we're going to try to get close to it. So 2.15 squared is 4.6225. And if I multiply that by 16, I get negative 74 if I'm going to round. So negative 74 plus 70, that equals negative 4. So sometime between 2 and 2.15, it's going to hit the ground, okay? If you want to try to get closer to 0, go for it. But I'm going to call that good enough, and I'm going to graph it there. We're working with positive numbers, so we only need that first quadrant. Okay, I'm going to go up by tens. So at 0, we're at 70. At 1, we're at 54, so about there. At 2, we're at 6. So that's about, well, it's about there. And then at 2.15, we're at negative 4. So about there. If I connect that in my parabola, assuming I can do that. Okay, so it hits the ground after, we're going to approximate this, so the little squiggly equal sign. Oops, if I can draw it. Let's say like 2.1 seconds. Okay, you're giving an estimate, just getting the general area of it. And there's your homework.